Let's start with the most common type, the stellar black hole. They're like the starter pack of black holes. Small, moody, and always hungry. A stellar black hole is born when a massive star finally runs out of fuel. Stars spend millions of years burning hydrogen, basically doing nuclear fusion 24/7. But when they run out of gas, gravity takes over like, okay buddy, I'll handle it from here. And that's where things get dramatic. When a smaller star dies, it becomes a white dwarf. No big deal. A medium one becomes a neutron star. Still weird, but manageable. But when a really big one dies, say 3 times heavier than our sun, it doesn't go quietly. It collapses under its own weight and boom. The outer layers explode in a supernova, while the core gets crushed down into a point of infinite density. A point so dense that light itself can't escape. That's your black hole. If you want a comparison, imagine taking the entire Earth and squeezing it down to the size of a peanut. That's how intense this compression is. Gravity on steroids. A typical stellar black hole weighs between 3 and 100 suns, yet all that mass could fit inside New York City. And the crazy part? It's invisible. It doesn't glow, it doesn't sparkle, it doesn't say hi, it's just there, waiting. So how do scientists even find these things? Because they're terrible at hiding. A lot of black holes have a normal star orbiting nearby, and they can't resist stealing from it. They pull in the star's gas like a cosmic vacuum cleaner, forming a glowing whirlpool of superheated material around them. That hot gas gives off X-rays, and when telescopes spot that glow, astronomers go, yep, found another cosmic criminal. The first time scientists discovered one was Cygnus X1 back in the 1960s. Fun fact, Stephen Hawking made a bet that it wasn't a black hole. He lost. Even genius physicists underestimate how sneaky these things are. And if the sun magically turned into a black hole tomorrow, same mass, just super compact, Earth wouldn't get sucked in. We'd still orbit exactly the same way, just in total darkness and freezing cold. So basically, gravity fine, vibes terrible. Supermassive black holes. If stellar black holes are the rookies, then supermassive black holes are the bosses. These things don't just sit around eating stars, they own entire galaxies. Literally, every major galaxy we know, including our Milky Way, has one sitting at the center like a cosmic CEO. Now, when we say supermassive, we're not exaggerating. These monsters weigh anywhere from 1 million to several billion suns. Imagine cramming the mass of every star you can see in the night sky into one single point. That's how ridiculous this gets. The one in the middle of our galaxy is called Sagittarius A star, pronounced Sagittarius A star, because even black holes want to sound cool. It's about 4 million times the mass of the sun, and thankfully, it's 26,000 light years away. So yeah, it's not sucking up your car anytime soon. But here's the fun part. Nobody's 100% sure how these things form. One theory says they start small, maybe as stellar black holes that just never stop eating or merging. Another says they formed right after the Big Bang, when huge clouds of gas collapsed directly into black holes. Either way, they're like the universe's early real estate moguls, buying up everything around them. And when supermassive black holes eat, they eat loud. The gas and dust swirling around them heat up so much that they shoot out enormous jets of energy, bright enough to be seen across billions of light years. These cosmic cannons are what we call quasars, and they're so bright they can outshine an entire galaxy. It's basically the black hole version of eating spaghetti so aggressively that the neighbors call 911. In 2019, astronomers actually took the first ever photo of a black hole, well, its shadow, in the galaxy M87. That glowing orange donut, that was the edge of a supermassive black hole, 6.5 billion times the mass of the sun. It's so huge that light literally orbits around it before escaping. Think about that. Light doing laps around a cosmic drain. Intermediate black holes. Now let's talk about the middle child of the black hole family, the intermediate mass black hole. If stellar black holes are the cosmic toddlers and supermassive ones are the billionaires, this one's the awkward teenager. Big enough to be scary, small enough that no one takes it seriously. For decades, astronomers couldn't even prove they existed. They were like the Bigfoot of space. Everyone had theories, but no one had a clear photo. Then, one day, we started catching hints. Strange X-ray signals, weird gravitational waves, and And people went, hold up, is that you, middle child? So what exactly is an intermediate black hole? Basically, it's one that weighs between 100 and a few thousand suns. Too heavy to be a normal stellar black hole, too lightweight to be supermassive. Think of it as the SUV of black holes, bigger than a sedan, smaller than a truck, but still wrecks anything it hits. These black holes might form when smaller ones crash together, or when a massive cluster of stars collapses all at once. They're thought to live inside dense globular clusters, those tight balls of stars hanging around the edges of galaxies. But they're so quiet and so far away that spotting them is like trying to hear someone whisper in a hurricane. In 2020, scientists found one that finally made them go, okay, this might be real. Two smaller black holes collided, and the resulting gravitational waves told us the newborn was way too massive to be a regular stellar black hole, around 142 times the mass of the sun. Boom. Proof that intermediate black holes are out there, doing their thing, smashing into each other like bumper cars made of gravity. Now, why do we care? Because these black holes might be the missing link that explains how those monster supermassive ones got started. You don't just wake up one day as a billion solar mass beast. You gotta work your way up. Merge, eat, grow, repeat. Kind of like going from eating ramen noodles in college to owning your own planet. Primordial black holes. Okay, now we're diving straight into the weird part of the universe, the primordial black holes. These things make normal black holes look boring. Why? Because they might be older than the first stars, older than galaxies, maybe even older than logic itself. Here's the wild theory. Right after the Big Bang, when the universe was just a chaotic soup of energy and particles, it wasn't perfectly smooth. Some areas had a little too much stuff packed together. And when you mix too much matter with too much gravity in too little space, boom, instant black hole. No dying stars, no explosions, just happy birthday universe. Here's a bunch of mini black holes. These are what scientists call primordial black holes, ancient leftovers from the universe's messy childhood. And the crazy part? They could come in any size. Some might be as tiny as an atom. Yes, an atom, but heavier than Mount Everest. Others could be as massive as the moon, but small enough to fit in your pocket if you don't mind vaporizing instantly. It's like the universe was testing its create mode and forgot to clean up afterward. So what happened to them? Well, if they exist, they're still out there, quietly floating through space like invisible marbles of doom. Some scientists even think primordial black holes could be dark matter. You know, that mysterious stuff that makes up 85% of the universe and refuses to show itself on camera. If that's true, then the universe is basically full of invisible black hole confetti everywhere, around galaxies, around us. Heck, maybe even passing through your living room right now. Don't worry, they're harmless, probably. But finding one, that's the real challenge. They're small, cold, and dark. Basically the ultimate hide-and-seek champions. Astronomers are using clever tricks, like gravitational microlensing, where they watch light bend slightly as something invisible passes in front of a star. If the light curve looks weird enough, it might be a primordial black hole waving hello from the dawn of time. And if we actually confirm one, that would rewrite everything we know about the early universe. It'd mean black holes didn't just come from dying stars, they've been here since before stars even existed. Rotating and charged black holes. Alright, let's crank things up a notch, literally. Because not all black holes just sit there doing nothing. Some of them spin so fast, they twist space itself like a cosmic blender. Welcome to the world of rotating and charged black holes, or as scientists like to call them, the black holes that make Einstein's hair stand up. Let's start with the spinning ones, also known as Kerr black holes. When a massive star collapses, it doesn't just give up all its spin. That rotation has to go somewhere. So the newborn black hole keeps spinning. And when a black hole spins, it doesn't just twirl like a ballerina. It drags space-time around with it. Yup, actual space is getting yanked around like water swirling down a drain. There's even a zone around it called the ergosphere, where space itself is being pulled so fast that anything inside is basically forced to spin along. It's like getting stuck on a cosmic merry-go-round that never stops. And here's the cool part. Theoretically, you could extract energy from that spin. Physicists call it the Penrose process, and it's sort of like stealing power from the universe's most dangerous fidget spinner. If humans ever figure that out, forget solar panels. We're going full black hole-powered Tesla grids. Now, on to charged black holes, also called Reissner-Nordstrom black holes. These are black holes that, in theory, carry an electric charge, positive or negative. Sounds crazy, right? A black hole with electricity? But it's possible, at least on paper. In real life, though, it's unlikely, because any black hole that tries to stay charged would immediately quietly attract the opposite charge from the universe around it, kind of like a lonely magnet, and neutralize itself. So, yeah, charged black holes might exist only in the theoretical section of the cosmic store. Now, if you take both spin and charge and mash them together, you get a Kerr-Newman black hole. This is the everything bagel of black holes: spinning, charged, chaotic, and completely impossible to deal with mathematically. It's so complex that even computers throw error messages trying to simulate it. But here's the takeaway: the more a black hole spins, the weirder the universe around it becomes. Space stretches, time slows, and gravity plays twister with the laws of physics. In short, some black holes don't just exist, they dance, twist, and electrify the universe around them, proving once again that space doesn't just break your brain, it spins it first for good measure. White holes and wormholes. Now, if black holes are the universe's garbage disposals, swallowing everything that gets too close, then white holes are the total opposite. They're like cosmic leaf blowers. Instead of sucking everything in, they throw everything out. Here's the catch: we've never actually seen one, not even once. White holes exist only on paper, a math-based fever dream born from Einstein's equations. But according to those equations, if space can bend in one direction to make a black hole, it can bend the other way too, to make a white hole. A white hole is like a black hole in reverse time. You can't go in, but stuff can come out. Imagine a volcano that spits out light, gas, and maybe a confused astronaut, but nothing can fall back in. That's a white hole. It's basically the universe saying, no returns, only refunds. So what's the deal? Some physicists think every black hole could be connected to a white hole through a wormhole, a kind of cosmic tunnel through space-time. You fall into one end, zip through some warped interdimensional spaghetti, and pop out the other side of the universe. Sounds awesome, right? Except there's one small problem: you'd be dead before you got there. See, falling into a black hole isn't like going down a water slide. It's more like being stretched thinner than spaghetti, and scientists actually call that process spaghettification. Yes, that's the real word. Physics has humor. Even if wormholes existed, they'd collapse instantly the moment something tried to travel through them, unless we found a way to hold them open with negative energy or something called exotic matter. So, until we figure that out, wormholes remain firmly in the cool movie plot category. But the idea still drives physicists crazy, because it might mean that black holes don't just destroy information, they could transfer it, like cosmic teleporters that send data somewhere else instead of deleting it forever. If true, that could solve one of the biggest mysteries in physics, the black hole information paradox. So yeah, white holes and wormholes might sound like science fiction, and they probably are, but they're also proof that even the universe has an imagination. It doesn't just make monsters, it makes portals, mirrors, and what-if machines. And who knows, maybe one day we'll look up, see a white hole appear in the sky, and realize the universe just sneezed. The fate of black holes. So, we've seen how black holes are born, from stars, from chaos, maybe even from the Big Bang itself. But what happens after that? Do they just sit around forever, like the universe's grumpy landlords? Or do they eventually die? Believe it or not, even black holes have an expiration date. And when they go, they don't explode in style. They just quietly fade away, one particle at a time. Here's how. Back in the 1970s, a guy you might have heard of, Stephen Hawking, dropped a cosmic bombshell. He said black holes aren't completely black. They actually leak energy over time through something now called Hawking radiation. Now, this radiation isn't like a flashlight beam shooting out. It's more like the black hole slowly losing weight, atom by atom, as tiny quantum particles escape from its edge. It's a bit like your phone battery dying at 0 point, painfully slow, but it's happening. For a normal stellar black hole, this process takes longer than the current age of the universe, like way longer. We're talking 100,067 years or more. That's a 1 followed by 67 zeros. By the time that happens, the sun will be gone. The Milky Way will be gone, and Taco Bell will probably still find a way to exist. But here's where it gets wild. Smaller black holes evaporate faster, so a tiny black hole the size of a mountain could actually vanish in a massive burst of energy. Basically, a final microwave popcorn explosion before disappearing forever. That's the black hole's grand finale, the universe's quietest fireworks show. So, what happens after they're all gone? Well, scientists think the far future of the universe, like trillions of years from now, will be called the black hole era. All stars will have burned out. All galaxies will fade into darkness. And the only things left shining, ironically, will be these dying black holes, slowly evaporating into nothing. Eventually, even they'll vanish, leaving behind a cold, silent universe filled with nothing but stray photons and math problems. So yeah, for now, black holes are eternal monsters, but in the end, they'll go out with a whisper, not a roar. The universe always cleans up after itself. It just takes its sweet time doing it.